Hey, how's it going? This is my physics lab for oscillating motion. So the introduction and purpose is that we want to examine the motion of a spring mass system in which the mass swings in an arc while oscillating on the spring. And we want to determine if the observed values satisfy the energy principle. So some models and physical principles that we use in this lab are the self-created computational model in GlowScript, Newton's second law, and the momentum principle, so position update formula, velocity update formula, forces, so force due to gravity and spring force, the energy principle, energy and work, kinetic energy, and then the different types of potential energy. So here's a preview of the results. We find that gravitational potential energy and spring potential energy switch back and forth. Kinetic energy oscillates, and the change in total energy is equal to zero, which is in line with the energy principle. So the system surroundings and initial conditions. The system is the spring and mass. The surroundings is everything else, and the initial conditions is the spring mass, which is the initial position, the length, and the initial velocity. So here's some relevant formula: the velocity update formula, position update formula, force due to gravity, spring force, and then kinetic energy, gravitational potential energy, spring potential energy, and the energy principle. So here's a diagram of basically what's going on. The force due to gravity points down, and the spring force points parallel to the orientation of the spring based off of whether the spring is compressed or stretched. So here's my tracker video and how I kind of recorded the oscillations. And then here's the glow script code. So this is the first part. Here we have the initial conditions at the top. And at the bottom, we're doing kinetic energy, gravitational potential energy, spring potential energy. Um, and here's the second part of my glow script code. This is within the while loop. So we have the initial energies, the force due to gravity and spring force. And then using those values, we do the velocity and position update formulas. And then using that, we use the energy principle. So the kinetic energy, gravitational potential, and spring potential energies. And here's a video of the program running. So as you can see, it kind of oscillates. Yep. So here are the results. We see that delta G and delta U, they go back and forth. So the green and the red lines. And then kinetic energy oscillates. That's the blue line. So it kind of goes up and down based off the motion of the spring mass system. And then the orange line is delta E. So we can see that is equal to zero, or at least close to zero. And then here's the predicted versus simulated data. So on the left, we have the tracker the predicted data based off of tracker. And on the right, we have the simulated data. So we can see they're very similar. It's just tracker is a little bit off because of human error. But this is how it should look, and they kind of just oscillate together. And here's some possible error. The oscillation period calculated using time values from the y direction, and the system is not actually closed, and therefore other forces are present acting on the mass. Some similarities and differences are just the oscillating motion is similar, and then there's slight differences due to the tracker inaccuracy. And why do we use these principles? So Newton's second law allows us to predict velocity and position. Energy principle allows us to understand how different types of energy are used. And then energy and work accounts for all the types of energy present in a system. What does it mean? Is the energy principle satisfied? So as we can say, our orange line, which is delta E, is equal to zero. So that means that according to what we did in our simulation, the energy principle is satisfied because K plus UG plus US is equal to zero. And then here we're calculating the oscillation period using the X data and the Y data. So as we can see, this is slightly different. And this does have an effect on the results because, we have different oscillation periods for X and Y. And one way we could fix this is just by doing an average oscillation time.